Assalamualaikum and hi everyone. So today we are going to explain about the GM counter for radiation detector. This presentation is presented by FATINAH MAHIRAH, ALEESYA MAISARA, FARAH BATRISYIA, AINAA NADIAH, and me myself IRDINA BATRISYIA. So we will start with the introduction first. Geiger-Müller counter, or we call as GM counter, is used for detecting and measuring all kinds of radiation, including alpha, beta, and gamma. It is widely used in the nuclear industry for many years. In the GM counter, it will contain a Geiger-Müller tube, which it will sense the radiation, process, and provide the results. In the Geiger-Müller tube, it will fill with a gas such as argon or helium at the lowest pressure and at the highest voltage. The GM counter is important for the nuclear physics research, medical uses, and environmental monitoring. It is because the GM counter can help humans to limit the radiation exposure to the environment and reduce the possibility of humans to get disease that caused by the radiation, such as cancer. The information of the independent learning was obtained from lecture notes, laboratory manuals, scientific articles, and journals. The challenge that encountered during this research was there are websites that explain in the simplest way, meanwhile there are websites that explain in the complicated way, such as in terms of equations. So to overcome this challenge, the information was combined from multiple sources so to make it more understandable.
The Geiger-Müller counter is a device used to detect ionizing radiation. It consists of a gas-filled tube that operates at a high voltage. When ionizing radiation enters the tube through the thin window, it collides with the gas atoms and removes some of their electrons, creating ion pairs. The free electrons are then rapidly accelerated toward the positively charged anode due to the high voltage inside the tube. As these electrons move, they cause further ionization of other gas atoms, leading to a chain reaction known as avalanche effect. This avalanche produces a measurable electrical pulse, which is recorded as a radiation count. Finally, the quenching gas inside the tube absorbs excess energy and stops the discharge, allowing the detector to return to its original state and be ready to detect the next radiation event.
This slide shows several everyday applications of the Geiger-Müller or the GM counter. Firstly, in the medical facilities, the GM counters are used to monitor radiation levels in the hospitals. They help to measure radiation around the X-ray machines, CT scanners, and radioactive materials to ensure the exposure remains within the safe limits for both patients and the healthcare workers. They are also very useful during the emergencies involving the radioactive spills or accidental exposure, that allowing the medical staff to quickly identify the source of radiation and assess contamination levels. Secondly, the GM counters play a very important role in the environmental and the public safety. They can detect the radioactive contamination in the food and water supplies, especially after the nuclear accidents or the radioactive leaks. This helps to protect the public health and increase the confidence in the safety of food and water. In disaster management, GM counters are used to locate radioactive sources that measure the radiation intensity, identify the contaminated areas, and support evacuation and safety planning. Lastly, the GM counters are widely used for educational demonstrations. They help students to understand more about the radiation safety, learn the proper handling of radioactive materials, and gain a better understanding of the principles of radiations. Students can also use the GM counters to study radioactive decay by measuring the count rates and analyzing data related to decay constant and half-life, also providing valuable hands-on learning experiences. In a conclusion, the GM counter is an important instruments that used in healthcare, environmental monitoring, public safety, and education to detect and measure radiation effectively. Now, I will explain about the advancements in the Geiger-Müller or the GM counter technology. Firstly, modern GM counters have improved sensitivity and detection efficiency. They can detect a very low levels of radiation that allowing a better environmental monitoring. This helps authorities identify the contamination at an early stage, improve radiation safety, and reduce the risk of accidental exposure. Secondly, GM counters can now be integrated with smartphones and mobile applications. Users can view radiation reading in real time, check historical data, and receive instant notification when the radiation level increases. This makes the radiation monitoring more convenient, accessible, and user-friendly. Lastly, advancement in the GM counter technology have enhanced the safety and emergency response. By combining the GM counters with GPS technology, radiation levels can be mapped across a large areas. This helps emergency teams to quickly identify contaminated zones, coordinate evacuations, and respond to radiation hazards more effectively. In conclusion, these technological advancements have made the GM counters more accurate, efficient, and practical for environmental monitoring, public safety, and emergency management.
So next, moving forward from the physics of gas application, let us explore how mastering the Geiger-Müller counters opens the vital avenues for professional self-development and career exploration in modern physics. The practical applications of radiation detection are directly tied to highly specialized essential professions. So, the first major career path that related to Geiger-Müller counters is becoming a radiation safety officer, or also we known as RSO. And RSO is a legally mandated professional in medical and industrial sectors who ensures that radiation exposure to workers and the public remains strictly within safe legal boundaries and not above the certain dose. On a daily basis, an RSO utilizes GM counters to audit radiology equipment in hospital, perform routine contamination sweeps, and manage dangerous waste disposal. This career path demands an intense interest in health physics and an unyielding commitment to public safety. Next, the second career path is an industrial radiographer or non-destructive testing specialist, or we call as NDT specialist. These specialists use high penetration gamma or X-ray radiography to inspect structural welds in aircraft hulls or oil pipelines. It is because they work with raw radioactive sources in unpredictable field environments. They must use portable GM counters as life-saving tools. They sweep the area to calculate the real-time dose rates, allowing them to map out of strict boundary lines and isolate the control area to prevent public exposure and to prevent the accident or anything that will become dangerous to the public.
Next, I will explain about the career opportunities that are related to GM counter technology and the importance of continuous development that are related to GM counter technology. As we know, the Geiger-Müller, which is GM counter, is widely used to detect and measure radiation. Because of this, it creates various career opportunities in fields such as healthcare, researchers, industry, and nuclear technology. For example, medical physics use radiation in medical imaging and cancer treatment, while a radiation protection officer ensures that workers and the public are protected from harmful radiation exposure. Another career option is becoming a nuclear scientist who conducts research that are involving radioactive materials and radiation detection technologies. To succeed these careers, individuals need a strong understanding of physics, especially radiation physics. In addition, skills such as data analysis, problem solving, laboratory techniques, and communication are also important. Besides academic knowledge, practical experience also will gain through laboratory work. Internship and research projects can help students to develop these skills. However, learning does not stop after graduation. Radiation technologies also continues to evolve with new instruments,
safety standards, and research developments being introduced regularly. Therefore, continuous learning is very important, such as professionals. They can improve themselves by attending workshops, participating in training programs, reading scientific journals, and keeping up with the latest technology advancement. Of course, pursuing a career in this field can be challenging because radiation physics is a complex subject and strict safety regulation must always be followed. Nevertheless, this challenge can be overcome through continuous practice, professional training, and commitment to lifelong learning. In conclusion, the Geiger-Müller counter is an important instrument used to detect a major radiation. Through this presentation, we have learned about working principles, components, application, as well as its advantages and limitations. The GM counter plays a significant role in areas such as researchers, industry, environmental monitoring, and radiation safety. Although it has some limitation, it remains a reliable and widely used device for radiation detection. As technology continues to advance, radiation detection systems are expected to become more accurate and efficient in the future.